this video, we are going to discuss the Post-hoc test in one way NOVA. In the last video, we discussed about the analysis of variance, which is used for the comparing of several means when our outcome variable is numeric and our factor variable is categorical with more than two categories. So in our example, we talked about like HbA1c, which was a numeric variable, and it has corresponding to it we had a categorical variable which is nothing but tension level, and it had T category hypertensive, non-hypertensive, and hypertensive. So to compare the means of the HbA1c among these three groups, we have to run the ANOVA with the hypothesis that all the means are equal, and the alternate hypothesis at least one of the mean is not equal. But when we run the analysis and we find that p-value is less than equal to 0.05, so it means at least one of the group has different mean. But which pair of group is different? This is not answered by the ANOVA. We have to proceed for some other analysis, which is nothing but the post-hoc analysis. Post is stand for after, and hoc is analysis. So it is like after the analysis of ANOVA. So ANOVA tells the difference among the groups exists, but to know which pair or group significant difference from another one, the post analysis basically run. For example, if we have three samples, three groups, so post-hoc analysis runs the null hypothesis for each pair of group. For example, if we have the three groups, so the group 1 will compare with the group 2, and then this group 2 will also compare with the group 3, and the group 2 compare with the group 3. Corresponding to each null hypothesis, we have the alternative hypothesis, for example, which is here. Mu1, like for the hypothesis, mu1 is equal to mu2, mu1 is not equal to mu2, mu1 is equal to mu3, mu1 is not equal to mu3, and mu2 is equal to mu3, mu2 is not equal to mu3. Conventionally, we do not write all the steps of hypothesis for this, so we are proceeding towards the analysis here. There are several post-hoc analysis tests. We will work on the tricky test because the application of the other tests are similar in SPSOs. We discussed about the example when we had 5 brands of tablets, and we admit it was which was administered to 25 subjects, and each tablets was given to 5 group of people. So we had 5 group, and each 5 group of people was given a single tablet, A, B, C, D, E. In the analysis, then we have to run the compare mean. Then we have to run the analyze, compare mean, and one-way ANOVA. And in the one-way ANOVA, since we had the option of time relief and the factor list, we have the option in the post-hoc we have to click the Tukey test. In the Tukey, when we select the Tukey, we'll press the continue. It presents a table like this after the analysis of variance. And although these there are all the columns which are mandatory, but we will work with this sig column, which is nothing but the p-value. And what this table referring to? It is actually the comparison of each tablet with the another one. For example, the comparison of A with the B, and the comparison of A with the C, and comparison of A with the D. Similarly for all the other analysis, and there are repetition also. So for example, to compare the means of the A and B to test whether the means of A and the mean of B were different, we have to proceed towards this one. This is sig value. This is the p value for comparing between the mean mean A with the mean B, mean time relief of the tablet A with the tablet B. Similarly, the second one, A with the C, the p value is 0.832, which implies the time relief of the time relief from brand A and from brand C. So since if the p-value is more than 0.05, we will say that the mean is not different in the two groups. But if the If the p-value comes out to be less than 0.05, so we will say the means are different. Like here, in our scenario, A does not A with the B has a p-value 0.201. With the C, it has 0.832. With the D, it has 0.201. With the E, it has 0.639, which implies the tablet A has not significantly not different mean than all the other tablets. Then we will move towards the other tablet like B. B and A has been compared in the first box. Then we will look towards the comparison of B with the C. Its p-value is 0.026, which implies that the time relief from the brand B and the brand C had significantly different mean. Then we had the mean of B and D, which is 0.002. It also implies that the time relief between the from the time B, sorry, from the brand B to brand D are significantly different. Similarly, we have one more group comparison, which is with the D and E, that which has the p-value 0.012. So in the conclusion, we can say that the time relief hour was not significantly different all the group. It was different in B with the T and B with the E, B with the C and B with the D, and the C and the D with the E. So we had three groups which produced significantly different, which was not detected by the one-way ANOVA. So this is our post-hoc analysis, and in one statement we can write that there is a significant difference in the time relay between the brand B and brand C, as well as in brand B. The p-values are this also, and also between the brand D and E. While there was no significant difference among the groups that took way on brand B, A, and B, C, D, etc. This is about the post-hoc analysis, how to conduct it when we run the ANOVA.